The UPS man just dropped off this crate. In this crate is our Zenith Rudder kit. Now what's exciting about the Rudder kit is if you can put this together, the rest of the plane is just as straightforward. So let's crack this open and get started. We'll take parts inventory, lay it out on the table, and see how our Rudder kit goes together. Whoops, sorry, you didn't get that, did you? In this presentation, we are going to build a Zenith Rudder. Doesn't matter which aircraft model you're interested in, a 701, 601, 750, or 650. The procedure for building the rudder is the same for all of them. Follow your plans carefully and watch just how easy it is to build your own rudder. Our very first step in our project is to lay out our parts and do inventory. Most kits will have a numbering system that will help you to identify these parts against the plans so that we know we're dealing with just the correct part. Let's take a look at the system that Zenith uses in identifying their parts. Each part is labeled, and here's an example of the vertical tail horn. The number on here is 6T5-3. Now, the 6 means it's part of the 601 or 650 kit, as opposed to one of the other kits that Zenith makes. The T stands for the tail group, so I know that this part belongs somewhere in the tail. This becomes more important when you're dealing with the entire kit and you have lots of parts that could easily be confused. So the T is for the tail group. The 5 means that I can find this part described and defined on page 5 of the tail group plans. The 3 means that on page 5 of the tail group plans, this will be part number 3. So every part should have a label on it, and it's our job as builders to first identify these parts so that we make sure we're not missing any and that we're not using the wrong part. This will become even more important when we deal with parts that look very similar to each other. For example, this L is not just any old L, but if we look at the part carefully, the number says 6T4-5. So we know that this is a custom part, and I can find it described on page 4 of the tail plans. That's what the 6T4 is for, and this is part number 5 on that page. Because we don't want to mix this up with another L angle that looks very similar but might be of a different thickness or dimension. Of course, I will have my plans available at all times so that I can find out the exact dimension, location, and position that these parts go together with. Do not use this video as the final say as to how parts go together. It's important to use your plans because plans do change from version to version, revision to revision. Very important to always use the plans, not the video, to make your final decisions before you drill. So what I have laid out on the table here are the parts that make up the skeleton of our Zenith Rudder. The parts that I don't have shown here are the skins, which we will deal with later. But we're going to build our skeleton first. It's made up of a number of ribs. We have a vertical tail horn. And notice the names of these parts are also located under the part number. So we can also refer to these parts by their name, although it is not quite as precise. We also have a main spar, and the spar has a couple of doublers that reinforce its corners. So with that information, and after we have made sure we're not missing any parts and can identify all of them to the plans, we can now begin our construction. Our very first step is to trim the ends of our doubler angles 6T45. Now both ends are the same, so you can choose either end. And looking at your plans, you will notice that they want us to trim off the corners on one side. I have drawn a mark 10 millimeters from the edge. I simply used my millimeter ruler and marked off 10 millimeters from the corner, and then drew a line to the corner. And that little triangle I'm going to remove using my snips. I'm going to use my green snips, and the reason is that the green snips will allow me to cut off a piece to the right. It will curl up. If I used my red snips, it would try to curl up the left side, and that doesn't make sense because that's the side we want to keep. So I'm going to take my green snips and cut just outside of the line. And if you haven't hit your neighbor in the eye, make sure you do wear safety glasses, because those little pieces will fling up and actually cause some serious damage. Now, we can't just leave it this way because these type of snips leave a ragged edge, so I'm going to use the file to clean this up and make a nice smooth edge to it. I'm just going to use my file. We could also use our 3M Scotch-Brite wheel on this also, but using the file is just as easy, and we want to get rid of all those tiny little bumps so that we have a nice smooth finish. Now that we have completed one of our doublers, we want to do the same thing to the second one. However, this one will be a little bit like the opposite, so that when they're facing each other like this, it makes kind of a V. So I did the same thing, measured up 10 millimeters from the edge, draw a line with your Sharpie, and remove it. And now we have both pieces cut and filed with smooth edges. Now we're going to work with the main spar, the large end over here to our right. And this is 6T4-4. Notice it is pre-drilled with lots of holes. This is going to make our work very easy because these are going to be the locations for all of the rivets after we do a final drill on all of the components. So it makes our work very straight, very precise. We're going to take the doublers that we just prepared with the cut off corners and place them into the corners of the spar, both corners. So notice that the edge that we trimmed is on each of the sides, and these doublers are going to extend beyond the edge of the spar by 30 millimeters. Now check your plans to get that measurement. Make sure you find that in the plans. I have marked on the doubler a line that represents 30 millimeters from the edge, and that way I can line up that line with the edge of the spar here. And I did that on both pieces. So these doublers will these doublers will protrude exactly 30 millimeters beyond the wide edge of the spar. I'll get that lined up just right, and they'll fit into the corner. Now, I'm going to use one of these clamps. Now, you can get these clamps at your favorite aviation store, but they have rubber tips which will protect your metal. And the idea is to clamp them onto the edge of the spar and the doubler, and that gives us a nice tight connection there. And these just squeeze with your thumb pressure. And I have another set then that I will clamp further down this way, and again holding them tight into the corner. The important thing here is that we make sure we are precisely 30 millimeters beyond the edge for both of them. Then we're going to turn this over and note the pre-drilled holes in the spar, and we're going to use our drill and drill through each of these holes all along the way. That makes it very easy to drill in the proper locations by simply using these holes as a guide to our drill bit, and we're going to do that on both sides. Now, rather than putting this on the table, and of course we have a problem because of the clamps, it's not sitting very nicely, and also we want to support the doubler underneath. So what I'm going to do and suggest is that you take a 2x4 block, cut it so it sets in there, and in fact I'm going to put another one down at this end that fits. And in fact, I'm going to use a second block to raise it a little bit higher, and then we can turn it over and have plenty of clearance so that when we drill, our clamps are not in the way. Now, I suggest as you drill that you move the block as necessary to always support the piece that you're drilling through, so you hold it tightly to the spar and also support the drill bit as it goes through. But basically we're going to start at one end after you're sure that these are extended the 30 millimeters. And in fact, always feel free to double check with your ruler before you drill, because once you drill that first hole, it's going to be a little hard to fix. And then we're going to cleco as we go. Now, the holes drilled in here are number 40 size pilot holes. I'm going to use my number 40 drill bit, which matches the same size of the holes, and then drill into the doubler below, and then use my silver cleco to attach it. So basically we want to get all of the holes in the back of the spar into the doubler. Now I have drilled every other hole on both sides and clecoed as I drilled. I'm going to go back now and drill through the holes in between, and it can set flat on the table when I do this, as it is now very well supported as I have removed the clamps. And I will continue all the way to the end. And we are finished when all of these holes have been drilled out on both sides. Later we will open these holes to their final size, which will be a size 30 drill bit, but we'll wait on that till later. Now, for our next task, we're going to remove these 4 clecos in this area here. And if you will locate rear rib number 1, which is 6T46, it's the large rib which will be at the bottom and has a flange on one end and also a set of pre-drilled holes on the bottom. We are going to locate it down at the bottom of the spar, and we're going to slide the flange underneath, or between rather, the stiffeners and the spar itself. And it's going to go like this and slide it underneath. Notice how I have the flange of the rib on the outside, and that's true on both sides, and I have it pushed in all of the way until it just about bottoms out at the corner of our stiffeners. And then the pre-drilled holes in the spar are going to be used to drill into the flange of the rib once we have it nice and straight. Here I have it hanging over the edge of the table so that the rib has room to clear the table. I've made sure that I pushed it in all the way, but not too tight, so that it just about bottoms into the radius, but not so that it's pushed hard. We don't want to cause any interference in there. And when I'm satisfied that I have it on there straight, I can go ahead and use the pre-drilled holes and use my number 40 drill bit to drill into these and cleco after I drill. I'm also going to support underneath it with a 2x4 block so that I'm drilling into the 2x4 and supporting the thin metal as I drill. That's always a very good habit to get into. And here I have finished it and drilled all 5 holes. Now we need 2 more holes that aren't pre-drilled in the corners, and the easiest way to locate them is to move these clecos, and what we're going to do is extend the rivet line all the way to the end. Same with up here. I'm going to use my ruler and just draw a line like that, and then I'm going to measure about 10 millimeters from the edge inward on both locations. And at those 2 locations, I'm going to go ahead and drill through the rib and the doubler underneath. And there we go. And as we are temporarily finished with this, we can uncleco it just so that it doesn't get damaged while we go on to the next step. I should also point out that if you'll notice on your plans, this rib flange will go on the outside of the spar when we finally complete the skeleton. It's a common practice to slip things in behind to take advantage of the pre-drilled holes and lining them up. If we had it on the outside in its final location, it would be difficult to match those holes up with the flange. So this was only temporary in this position for the purpose of drilling. In preparation for installing the ribs, we want to locate their placement on the spar ahead of time. Now at the very bottom of the spar, we just removed rib number 1, the large rib. As we move up the spar, we're going to look for the first set of pre-drilled holes that cross the spar and label that as rib number 2. And we want to label this on both sides, the back side of the spar also. We keep moving up the spar and we will come to a set of double holes that run across the spar. The first set of holes is the placement for rib number 3, and right above it will be the placement for the nose rib. And as we keep moving up towards the top of the spar, as it gets narrower, we will find the last set of holes, in this case 3 holes, that spans across the spar, and label that as the location for rib number 4. Make sure you label these on both sides of the spar, not just the front but also the back, where some of them will be located. Let's look at 3 of the ribs we'll be installing next. We have rib number 2, the largest one, then rib number 3, and rib number 4. Now if you look at your plans, they each have a part number. Rib number 2 is 6T47, and rib number 3 is 6T48, and rib number 4 is 6T49. And those are all labeled on your plans. We do want to examine the plans closely because some of these ribs are mounted with their flanges up and some of them with their flanges down. And this is a good time to label this after we check our plans so that we don't install them backwards. So rib number 2, the largest one, has its flange pointing up when we install it. So I marked up with an arrow pointing that this flange is going to go up. So ultimately it will be positioned this way, the flange facing up. And in the case of rib number 3, this flange also will end up being up, so it will ultimately go this way. And in the case of rib number 4, the flange will be down, so its final location will be this way. And for me, that's referring to this flange, not this flange, because if you look at rib number 3, notice that the mounting flange is opposite the actual flange of the rib. So mark them as necessary so you don't install them upside down. To determine this, simply look at your plans and it will show you the final position of the flange in your plans. So we have these 3 ribs prepared. We have one more step, and that is on the mounting flange at the end here. We want to mark the center line of the flange, and that simply means to carefully draw the center line all the way across. My flanges are about 18 millimeters across, so I simply marked the 9 millimeter mark at both ends and connected it with a ruler. Very simple, but you want to try and keep that center line somewhat accurate, and you want to do the same for each of the other ribs. We're going to use this line to help us position the rib very accurately into the spar. Now we can install rib number 2. We marked the location through the pre-drilled holes where rib number 2 will be located. And I also labeled the spar up so that there's no confusion that the top of the spar is in this direction. So what we're going to do is take our rib number 2, and remember we labeled the flange up, so we know that that goes up, and we have the mounting flange with the center marked. So I'm simply going to place this underneath and look for the line on the mounting flange through the pre-drilled holes. Now, you may not be able to see, but I can find the line by moving the rib around and see it through all 4 holes. Now, what I want to do now is clamp this flange in place so that it doesn't move as we prepare for drilling. To clamp the rib in place, one of the nicest tools is a clamp like this. It has a nice reach which we need around the flange and allows you to adjust it by screwing in the peg in and out, and it's also cushioned on one side with the rubber insert. You can also use a C-clamp. That would work also, but we certainly want to keep it tight while we're drilling to keep it from moving around, because its location, its precise location, is very important. Here's another view of the clamp in action. And we're going to make sure we find the line, the center line on the flange, through all 4 holes. I am also going to use a block underneath so that I can support the flange nice and tight while drilling. And then cleco, and I'm drilling with a number 40 pilot bit, and then I will continue on till I get all 4 of them. We have all 4 of them drilled, and it will look something like this. Notice the flange is up towards the top, and we are right through the center of the flange as we want it to be. We're now going to continue up to rib station number 3 and repeat the same procedure, clamping it, looking for the line through the center, and carefully drilling. Also from the back side of the spar. And don't forget, with rib number 3, the flange goes up, but the mounting tab is down. That doesn't change anything. We're still going to look for that line through our pre-drilled holes. And clamp it in place securely. And again, going to support it with a block of wood. And drill. And there's rib number 3. And we have one more rib to do, and that will be rib number 4, located up here. And again, note the location of the flange that you marked. This time the flange goes down. And I've turned the spar around. I've also removed the ribs from down below so that it would sit on the table, and can now install number 4. Remember, the flange goes down. And there we go with rib number 4. Now I'll remove this and we're going to install the nose rib. Here is the nose rib 6T4-1. I have marked the mounting flange with a line right down the middle. And remember, the nose rib, the flange goes down. Check your plans to confirm that. Now, the nose rib's going to go on the front of the spar, not the rear with the rear ribs. So on my spar, I reverse the clecos, which used to be coming out of the bottom. That way I can set the spar down flat because we're going to mount the nose rib on the front of the spar. And remember, we labeled both the front and the rear of the spar. There's our rib number 3, and right above it was the nose rib. So our nose rib is going to be mounted like this on the front of the spar. And of course, we're going to look for the line through the pre-drilled holes. And also, we need to make sure that the nose rib is centered left to right properly. So when you clamp it, you may want to move it left to right to get it centered just right on the spar, in addition to making sure that the line can be visible through the pre-drilled holes. So I will clamp this up and get ready for drilling. Okay, I have it from left to right, just right. You can also put a small scrap of metal along the edge just to confirm that it is left to right, just right. And through the pre-drilled holes, I see the line, and make sure you have it on the correct set of holes, the ones marked nose for the nose rib, and use your small block of wood underneath while drilling. And there we go. And there is the nose rib. And now we will prepare the tip rib 6T4-2. On the underneath side, our first job is to draw a line 50 millimeters from the tip, measured back, and draw a line across. Check your plans for this dimension. What we're going to do next is use our rudder tip angle. This is just a bent piece of aluminum, but it has a part number 6T5, short flange and a long flange. And I have located 2 places that we're going to have rivets. Basically 10 millimeters in from the edge, and then equal distance from each of the other edges. And what we're going to do with that is place the bent angle up to the line so that the tangent of this bend comes right up to that line. And then I'll first pre-drill 2 holes in the bent aluminum, and then holding this to that line, drill it into the tip rib and cleco. And there it is, up to the line, small flanged, clecoed to the web of the rib. Now the longer flange is going to attach to the tip of the spar. And there are 2 pre-drilled holes, and this will go on the inside and will sit just like this. Now, the directions, the plans say to keep a tiny 1 to 2 millimeter gap between both of the flanges. So they should not be touching, they don't go inside of each other, but a gap. So once that is in there and centered from left to right, I can go ahead through the pre-drilled holes, which are located right here, and drill into the larger tab. Check your plans to verify. And here I have it drilled, and notice it's free to move with a tiny little gap, just as our plans ask for. And that completes all of the ribs, from the tip rib to the bottom rib. Our next step is going to be to go through all of our holes and open them up to their final size. And if you look at your plans, you will see that the majority of them are going to be A4 compatible. In other words, they're going to be a drill bit size 30, which will allow an A4 rivet to fit through. Double check your plans to confirm that that is true, but I'm going to go through and open all of these up while the parts are clecoed together, and open them up using a drill bit size 30. As I drill out the holes to size 30, I replace them with a copper colored cleco, and that way I can remove the silver clecos and drill those holes out to size 30. So every hole eventually has to be drilled out to your final size at this time. And then we're going to disassemble everything for deburring. We should take this time, with all the components disassembled, to draw a center line on the flange of each and every rib. With each and every component disassembled and drilled out to its final size, it is time to deburr, or to remove the little burrs that are created when you drill through metal. Now, I use a combination of using a piece of Vixen file and that's probably the fastest way. That makes a nice smooth surface by knocking off everything above the flat surface. You don't have to worry about these scuff marks. That doesn't hurt the metal in any way. And another technique I use is the deburring tool from your aircraft supply store, and that takes a single turn in each hole, no more than that. Whichever you like, easier or faster. And every hole, both sides, needs to be deburred using either one of those methods. And an alternative is using a drill bit and again making a single turn like that. You might want to wrap the drill bit with tape so you don't cut your hands. And let's remember, the reason deburring is so important is that if we didn't, those little nubs that stick out would prevent this from resting tightly against the adjoining metal. And the surface contact is responsible for a lot of the strength in parts that are bonded together with rivets. So any gaps that we impose between this and the part that it's going next to would reduce its strength. So by keeping this nice and flat, that will give us the strongest strength, the greatest strength, when connecting this to another component. If you need to remove one of these stickers from the metal, using something like lacquer thinner and placing some on a rag, and then simply rubbing it on the label, allows it to come off very nicely. Almost like magic. And then just a little more lacquer thinner will take off the residue. And that way you don't have to spend a long time trying to get all of those labels off. Certainly don't want to leave them on under a rivet head anyway. I have deburred all of the holes, both sides. Now it's time to add our protection. Now I'm going to demonstrate applying Cortec, which Zenith supplies. It is a water-based coating that goes on, so it's relatively safe for the air in your hands, etc., compared to some of the other more paint or solvent-based corrosion protections. So this is an area that you can do your own research on, but I'm going to show you what I'm going to do for the components in this rudder that I'm building. Now the first step before applying any type of coating is to scuff up the area. So I'm using a pad of Scotch-Brite, and this doesn't hurt the aluminum, but I'm going to go in here and just scuff up the aluminum. That scratches it up. It allows the coating to adhere to the aluminum a little bit better than if it were perfectly shiny and unscuffed. Now I've decided to apply the corrosion protection just to the areas where two pieces of metal will come in contact with each other. For example, in the corner of the spar where our doublers are going. And the idea is that instead of coating every surface with the corrosion protection, we can save material by not coating everything, and the idea is that corrosion will possibly start where water is trapped between two metals. So that's why I'm only coating the surface that comes in contact with other metal components. Because we know when two metals come in contact with each other, even if they're the same metal, a degree of electrolysis will occur if there's moisture in there, and that's where corrosion begins. So that's the theory upon which I'm doing this. Now Cortec comes from Zenith in a can. They obviously break it down for much larger quantities. A quart will last us a very long time, much more than is needed for our rudder. And then I put just a small quantity in a glass jar. And this is thinned with denatured alcohol, so as the solvent evaporates, it'll go thicker. And so the first step, as I mentioned, is to scuff it up with the Scotch-Brite pad. Then I'm going to take lacquer thinner on a rag and then rub down the area with the lacquer thinner, and that will remove any dust and oil. And now I am able to apply the Cortec coating and give it the best possible chance of adhering to the surface. Let me demonstrate. I'm going to use a foam brush and then just apply a light coating. And that's all we have to do. And that's it. And if necessary, we can thin this if it doesn't flow as nice as you would want it to. And we're going to let that dry. And of course, I'm going to do the same thing to the stiffener that's going to go on top of here, but I'm only going to assemble the parts after this is fully dried, and this doesn't take long. After about half an hour, that'll be absolutely nice and dry. So I'm going to continue applying my corrosion protection to all areas of the rudder skeleton that come in contact with other pieces of metal by using that procedure. I have reassembled the skeleton together. I only installed the lower large rib so that I could place the skeleton onto the table flat. So I have the spar laying flat on the table. I do have the doublers clecoed in place. The only thing I left off are the other ribs. We're going to begin riveting, and if you're brand new to riveting, this just makes it a little bit easier to have it flat on the table. Soon you'll be riveting in any position you want, and you could then assemble all of the ribs at this time. For now, we'll just start with riveting the doublers. Whether you're going to rivet with a hand riveter or with a pneumatic power riveter, the principle is going to be the same. The most important thing is to make sure that we have drilled the proper size holes, because then we can use the proper size rivet as called for in the plans. Now, my plans called for A4 rivets in the rudder skeleton. A4 rivets required a number 30 size hole, so I've already drilled out to size 30, and I have my copper clecos in about every third hole, holding it together securely. So I'm going to insert a rivet into one of these holes. I like to start at the center and work outward. There are basically two sizes in the Zenith kit, and I'm holding the A4 rivet size, which is the smaller. The larger is the A5. With the A4, I can go ahead and just insert it into one of the holes by simply pressing it down as far as it will go, and then I can use either my hand riveter or power riveter. Now, before I go and rivet, we want to make sure we have the proper head in the rivet gun. Now, Zenith supplies two sizes, a smaller one for the A4 and a larger one for the A5. So make sure you have the smaller head screwed into your gun, the smaller nose piece, this just unscrews, into the gun so that it properly forms the rivet head. I'm going to demonstrate first with the hand riveter. I'm simply going to insert it. I'm going to make sure I'm pushing down to hold that rivet tight against the surface, and I'm also going to make sure that I keep the nose perpendicular to the surface. Don't hold it at an angle. And I'm simply going to squeeze, and usually it just takes about 3 squeezes. And that pop breaks off the stem and leaves the rivet in place. Now, if we take a nice close look at this rivet, we'll see that it is tight to the surface. It's not up. There should be no gaps. You shouldn't be able to even squeeze a credit card between the surface and the lip of the head. It should be all the way tight. That way you know you have properly set the rivet in place. And that's all there is to it. And we're going to continue on riveting in both directions. And eventually we'll fill up all of the holes and have to remove the clecos and then rivet in those holes. Now, if you're doing the spar like I'm doing here flat on the table, make sure you don't rivet in the locations where the ribs are supposed to go. In fact, I've put clecos in the rows where the ribs are located because we don't want to fill up those holes until we cleco the ribs on. So I'm going to rivet all of the non-rib holes in the spar, which is basically attaching the doublers on the corner inside. And then once I'm done, and that will also include riveting the large rib at the bottom, then we can set this assembly sideways on our table and attach the ribs and rivet them. Now here's a demonstration using the power or air pneumatic rivet gun. We have exactly the same nose piece. Make sure you have the proper nose piece for the A4 rivet. We can either insert the rivet right in the nose piece or insert it into our work and simply Place the nose piece and the stem into the gun. Make sure you're pushing down very lightly just so that it is secure against the surface, and pull the trigger. And that will very quickly provide a nice riveted joint. And again, you want to inspect that there is no gap. The rivet is flat down against the surface. That's the most important thing. If you find out that your rivet has somehow jumped above and you can slide something underneath that lip, then we would need to drill this rivet out and set it again. Now I'm going to use the pneumatic riveter for most of my riveting just because it's much faster and a little easier on the hand to fill the holes. I have filled all of the holes that were open, other than the ones for the ribs, and so now I'm going to remove the copper colored clecos and fill those holes with rivets. Again, not removing the clecos from the rib locations because we don't want to fill those holes yet. Now I have turned the spar on its side and have attached each of the ribs in their proper location with a couple of clecos, making sure I have the orientation of the flanges correct as they were previously marked. As we are now ready to rivet the ribs in place. Let's take a look at rib number 2. I have clecoed the outer 2 holes of the ribs, and I'm going to rivet the inner 2 holes and then remove the clecos and rivet the outer 2. So we're going to rivet from this side of the spar. Sometimes you have to wiggle the rivet in. And I'm also making sure behind the spar that I'm holding the flange tight to the web of the spar. And then rivet. And of course you want to adjust your rivet gun with the proper air pressure as per your directions so that it pulls the rivet properly. Not enough air and you won't get the pop, it won't pull the rivet, and too much air and it will bounce real hard. We're going to make sure these rivets are nice and tight to the surface so there's no gap in there. And we can look at the other side just to confirm that we got a nice tight fit. I'm going to continue this for each of the ribs until I have completed. The only rib I have left off so far is the nose rib, and I will do that last. So be sure not to put rivets into the area where the nose rib goes. But rib number 3 behind here, of course, we will do that. And this is dried Cortec anti-corrosion coating because the nose rib is going to go in that location. Now we're going to rivet the nose rib, and it's a little easier for this riveting to use the hand riveter because its nose can get in there a bit easier than the pneumatic riveter. And now we're ready to prepare for the skin installation. And here is the trailing edge skin. Notice that it is cut to size and virtually all of the holes have been pre-drilled in the skin. So this is going to make our job very easy. Now when handling the skin, do be careful. It will crinkle and bend, so you want to be careful. Use two hands. I like to carry it from the open end. The opposite side has a bend in it already, and we want to respect that and not crush it or otherwise change it. So just be careful and always carry it with two hands like this. Now the only preparation we really need to do with our skin is to dull or deburr the edges. Now these edges, when they're cut with a large cutter, leaves a very sharp edge, and we need to use our file or a edge deburring tool to take off the sharpness of this. And that also, in addition to preventing yourself from getting cut while handling it, also keeps the skin from developing cracks, because we don't want any sharp edges where cracks could theoretically occur, especially with all the stresses and vibration. Remember, the skin in many of the components of this aircraft, the skin is used as a structural component and is under stress. It actually gives the part its strength. So we want to prepare this properly. Deburring the edges of our skin can be accomplished with a deburring tool. Here's one example of that. Notice the V cutter in there, and we will slip the edge of the skin in that V, and that will cut off the sharp edge. There's a number of variations of this tool, but they are all deburring or edge deburring tools. To operate this, I'm simply going to drag it with some firm pressure, but not too much, along the edge, and I can feel it cutting the sharp edge off. If I need to take a second or third pass, I can do that. Our goal is to just get the sharpness off the edge, and it should be dull so that it doesn't cut you. So I'm going to carefully do that along all of my edges. Another alternative is just to use your file, and a file only does its job in one direction, so by I can take off the sharp edge by rubbing it along the edge. Now, as we prepare to install the skin on the skeleton, notice that I have rested the skeleton on a set of beams. Now, these happen to be 2-inch square steel beams. You can use another material like a 2x4 or other such thing, as long as it's nice and straight. Now, this one is laying flat on the table. This one over here is flat on the table down at this end, but notice I have a block. I have raised it up by 3/4 of an inch right at the location where the bottom rib sets. So in other words, we're raising the bottom trailing edge of the rudder up by 3/4 of an inch compared to the top. And the reason for that is, once you finish the rudder, you will notice that it doesn't sit flat at the trailing edge. It comes to a bit of a point here. So we want to make sure that the skeleton is in the proper configuration so that when we put the skin on and rivet it on, it holds that shape the way it is supposed to be. Otherwise, if we didn't have that block in there, we would end up riveting in a twist and the elevator would come out crooked. So be sure to support the bottom trailing edge by just putting a 3/4 inch block and raising that area up. And even if we need to flip this over, and another reason we're using these beams is that as we start to rivet and cleco, we want to be able to turn the skeleton around and not have the clecos touch the table. So we're holding the rudder off the surface of the table so the clecos have room to sit and hang rather than touch the table. And I'm simply going to slide the skeleton inside of the skin. And it's pretty obvious how the skin fits. We'll get the bottom to line up, and the front edge should line up with the front edge of the spar. And we can move it up and down. Now you notice how there's a little bit of flex in here. What we can do is, if you'll take a ruler or other thin but somewhat rigid object and place it underneath, that will help keep the skin a little more rigid underneath. Notice I have placed tape, duct tape on here. That is after I got the skin lined up exactly the way I want it. Let's take a closer look at how I went about aligning the skin to the skeleton accurately prior to drilling. I have positioned the skin so that the bottom edge lines up with the bottom rib, and the front edge of the skin lines up with the edge of the spar. And as far as positioning the skin from left to right, it's important that I use the pre-drilled hole line in the skin and make that line up with the pre-drilled holes in the spar that we riveted. And then position the skin left to right until that situation occurs. And we can check along the rest of the edge of the spar for that situation. Notice also that the holes in the skin line up with the center of our nose rib. And when we have the skin in place just the way we want it, we can add additional duct tape to hold the skin firmly in place so that it does not move. Once we are happy with our skin alignment, we can begin drilling starting from the trailing edge towards the spar. I will begin with the bottom rib. I'm going to drill every third hole and then cleco them. I'm going to make sure and hold the skin nice and tight while drilling. When we start moving up to the next rib, before we drill into this next rib using the pre-drilled holes, we first want to make sure we can see the line that we drew on the flange of the rib. The way to align the rib is to lift and stick your hand and grab the rib inside and move the rib up or down as necessary until you can see the line appear through these holes. So don't drill until you can see the line, that center line we drew on the flange. And that'll be true before we drill any of the ribs that are inside, so that we get right into the exact center of the flange. That's why we drew the line on those flanges. I'm going to begin my drilling by drilling into the lip of the spar at the location where the rib meets. So I'll have one here. Then my next rib is over here, so I'll make another. So I will drill here. I'm going to use a number 40 drill bit with the silver Cleco, and then move up to the next rib and drill into the spar. And that will hold the skin in place for the remainder of my drilling. And notice I've even placed one into the spar up at the very top, just short of the top rib. This way the spar now is lined up with the skin just the way we want it, along this front edge, and we can now move to drilling the ribs. I'm going to use a number 40 drill bit and silver Clecos, starting at the very rearmost hole and then working our way forward. And now that I have the bottom rib done, I can start on the next rib up. Again, making sure that I align the rib so I can see the center line through the holes, starting at the trailing edge and drilling towards the spar. Now that rib 2 is complete, I will start on rib 3, starting at the trailing edge, and again aligning the rib till I can see the center line through the holes, and then drilling forward. And now we can proceed to rib number 4 and do the same. And with rib number 4 complete, we can move on to the very top rib. Now notice I have placed a ruler underneath this edge to add a little more rigidity to the skin. We can now swing this top rib in and out as necessary to get a good fit along the edge. So I will hold it in place. I will make sure I get a nice solid contact starting at the back and drill forward every other or every second hole and Cleco. Now that we have drilled all of the ribs, using our number 40 drill bit, we're going to drill the rest of the pre-drilled holes in all of the ribs. Notice I am not drilling the holes in the spar at this time along the spar. We'll do that later, but we do want to finish drilling the holes in the ribs. After drilling now, we're going to flip the rudder over so we can work on the other side. We're still going to use our steel beams, and we still want to support the bottom aft edge with our spacer block. So let's turn this over. We've turned the rudder over. Notice that at the bottom trailing edge, we still have our block raising the beam up 3/4 of an inch. So that's important when we're drilling, so that we don't introduce a twist into the rudder. Now we're going to do the same thing, start at the trailing edge at the bottom, holding it down firmly and drilling every third hole and Clecoing with our number 40 drill bit and silver Clecos, and then working our way up the other ribs, starting from the trailing edge, coming forward towards the spar. And if necessary, we can still tweak the position of our ribs by lifting up and sticking our hand under and nudging the rib up or down to make sure we get the center line right through the hole, so that we're drilling as close to the exact center of each of the flanges of the ribs. Our next step then is to drill with our number 40 drill bit all of the holes in between the clecos. In other words, finish drilling through all of the pre-drilled holes in the skin and into the ribs. Now we're going to install the leading edge skin 6T51. We want to handle it carefully. It comes with a pre-bent nose, and there's a short end and a long end. The short end will go at the top and the long end at the bottom. They will wrap around our nose rib and our tip rib, and we will have to bend it slightly to install it. Now we're going to slide it underneath the skin, the leading edge skin of our rudder, because that has the holes in it, and we will use those holes as a drilling guide. So we will slip it into or underneath the skin and the rudder on both sides, about 20 millimeters, and push it all the way up to the tip rib and the nose rib. Here we will just carefully slide it underneath on one side first, and then worry about bending the other side into place. Each side goes in approximately 20 millimeters, and ultimately we will want to make sure we have the same amount slid in on both sides so that it is even. So I'm going to fold it over and start to work the bottom edge underneath the skin. But again, be careful, because we can ruin this skin if we don't keep even pressure on it. And I'm simply going to start it underneath and then until I can get it all the way in. And another set of hands could be very helpful. You can't have too much help. And so our goal is to get it underneath the skin and pressed in as far as it will go, which should be about the same as it was on the other side, about 20 millimeters in. Certainly past the set of holes here. We know we've got this pressed in enough when we can get it nice and tight so that we have no gap up in there. And also notice I've used a piece of duct tape to hold it, and we don't want it slipping out. So when we have it all the way in up at the top, we can work our way back with the same purpose. And this should give you an idea of the way the skin looks at the top. Notice that we have it such that the top of the nose skin dead ends into the top of the main skin, just at about this location here. We're going to end up trimming off this piece. We'll do that a little bit later. Now we're viewing it from the other direction so that you can see the nose rib. So notice we have pressed the skin in as far as it will go, with the goal of getting it tight to the nose rib. Now we want this nose rib to be 90 degrees to the spar. 90 degrees to this spar here, and pushed in so that it is nice and tight. In fact, one way to do this is to have the nose rib something less than 90 degrees to the spar, push it in, and then by pushing the nose skin all the way to 90 degrees, that will force it even tighter against this. I've also put a piece of duct tape to hold it in place. So our goal is to get the nose skin tight to the nose rib and then tight up to the tip rib at the top, and then we have it in place. Now I'm going to pick up the rudder and flip it over confirm that the other side is in as far as it should go, and duct tape the other side, because we want this secured very nicely on both sides prior to drilling. Now in the front nose rib here, we want to use a square to determine that the rib is 90 degrees to the spar. So by using a square up against the spar, we can test that we have the rib properly positioned in that direction. Now, obviously we want our duct tape on so that we have it nice and tight, especially when we squeeze it against the flange of the rib, so that we keep it tight all the way into the nose. Now we are ready to drill the nose skin on. Before we do though, make sure you have the rudder back on your beams with the trailing edge at the bottom raised up with your block. And we're simply going to use the pre-drilled holes, but we will start at the center using our number 40 drill and drill out from the center, going in both directions, clecoing every third hole, drilling and then clecoing every third hole. And of course we're going to make sure we hold things down nice and tight as we drill and cleco. And now we have drilled and clecoed into the main skin, the nose skin, and the spar. I'm going to go ahead now and drill in between the clecos to get all of the pre-drilled holes. And once we do that, we want to turn the rudder over and do the same for the other side. Of course, remember when you turn the rudder over to be sure to place it on your beams and make sure that the bottom trailing edge is on the beam that is raised up at that location by 3/4 of an inch. I'm also going to take this opportunity to drill the rest of the spar. So I'm drilling all of the pre-drilled holes at the edge of the main skin into the flange of the spar. And I'll do the same on the other side when I flip it over to finish off the nose skin. At the top of the rudder, where the nose skin wraps around the very tip of the top rib, we want to trace with a marker so that we can remove this excess area later on. I'm just going to take a pen and mark in here. Now we need to prepare and draw the rivet line for the nose rib. So we first have ensured that the nose rib is at 90 degrees to the spar. So I used a square and I looked inside and made sure that that nose rib was 90 degrees to the spar. Once we have done that, I extended the line from our rib on the other side going straight, and this should be the center line of the nose rib flange. And I simply used a square, because remember we made it square from the spar. And make sure you look at your plans, but on my plans it wanted a rivet spacing of pitch 40 roughly. So I measured from this hole 40 over 40 millimeters and 40 millimeters and 40 millimeters. However, you need to look inside to avoid the crimps on the flange of the rib. So adjust this 40 spacing for your drilling for your rivet locations by moving it one way or the other to avoid the crimps on the rib. So just look inside when you place these locations for the rivets. Here is a view of those crimps that we need to avoid when choosing our locations for the rivets. And of course, we're going to turn the rudder over and repeat for the other side of the nose rib. Now, our next step is to drill out all of the holes we've drilled thus far with our final size of the hole that we want for the rivet, which is a size 30 drill bit for the A4 rivet that will go in these holes. So what I'm going to do is drill a size 30 hole next to each and every cleco, and then insert a copper colored cleco in that 30 size hole, and then remove all the silver clecos and drill every hole out to its final size, size 30. So essentially, all of the silver clecos will be replaced with copper clecos, and all of the holes in the rudder, both sides, will then be A4 rivet. And that will be our next job before we disassemble and do some final trimming. Now, both sides have been drilled out to accept an A4 rivet. That's drill size number 30. We're now going to disassemble the entire rudder, take it all apart. We have some trimming to do and plenty of deburring before reassembling and riveting. Now here's the nose skin. I have removed it, and we're looking at the inside of it. Notice I have drawn a line along both edges. This line is exactly 10 millimeters from the center of the hole. We're going to trim this edge off. The nose skin is going to go on the outside of the rudder skin. We placed it inside in order to drill the holes, but it will be placed on the outside, so we want to trim so that we don't have any more material than the 10 millimeters from the center of the hole. So we want to cut this very nicely and then file it, because it will be an exposed edge on the rudder. So we're going to draw that line on both edges and trim carefully with our snips. Now, after we cut the edges off, like we just talked about, we need to come up to the top and cut off the tip. And here's the outline we made when the skin was on the rudder. And we used our pen to draw the part we want removed. Now, this will be a little more challenging. One way to do this, and I say it's more challenging because of the curved nature of what we're cutting here. If we take our red snips, and normally with our red snips, the part that we don't want gets curled off onto the left side, but if I'm going to turn it upside down and cut this way, and that will effectively force this piece then to curl down and away. We could turn this around and cut it the other direction, but this is just one way that might work. And I'm also going to trim outside of the line. I'll make my final cut with the second or third pass, because you only get one chance to do this. So I'm going to cut about 1/4 inch, just so I can get the feel of how that's going to work. And notice how the material here is curving downward, which is good, kind of down and out of the way. And I'm using just small cuts because we have a bit of a curve down here and we want to try and follow that. Now I'm just going to go back and cut again till I remove my line and make that look as nice as possible. I can always then file to get rid of the teeth marks. We are now ready to deburr all of our components, the skins, the skeleton. We want to deburr carefully and then also apply our corrosion protection, especially to the surfaces that will be contacting each other. After we do our deburring and corrosion protection, we then need to reassemble the entire rudder using our copper-colored clecos. Once we have re-clecoed all the parts together, and I have a cleco about every third hole, so you don't have to cleco every hole or every other hole, but you can have 2 holes in between each cleco, we can go ahead and rivet. Now it's important to make sure that before you rivet, the entire rudder is sitting properly on your beams, and remember the bottom trailing edge is elevated by 3/4 of an inch, because as you rivet now, it's going to solidify all of your connections. When you rivet, it'll tighten everything up, so we want to make sure it's sitting flat properly on the beams like we talked about before prior to riveting. I do want to point out that the area below the nose, hold it up here, this area down here below the nose skin, we will not rivet this line along the spar on both sides. We will not rivet that. That's because there will be another fairing that fits in here when we mount it to the fuselage. So the only thing we're not going to rivet again is on both sides, this area along the spar flange from the bottom of the rudder all the way up to the nose. And also don't forget that the nose skin is clecoed to the outside of the rudder, to the outside of the main skin. It is not tucked in between like we did when we were locating the holes and drilling it. It will be on the outside. And after we rivet one side, we can then flip it over, set up our beams properly, and rivet the other side. And that will finish the rudder until we are ready to mount it onto the fuselage. When riveting, it's best to start with the ribs and start at the trailing edge and rivet towards the spar. And do that for each rib, from the trailing edge toward the spar. And what that does is tend to press the metal away so that if there's any excess of skin or ripples, it'll try to stretch it forward. And when it comes to the spar, I like to start in the middle riveting and then rivet from the middle outward. And again, that tends to push, if there's any loose metal, and stretch it outward so that it has a place to go. Now remember, below the nose skin, we don't want to rivet into the spar flange at this time because there will be a fairing that we're going to slip underneath there. So we'll hold off on that until we mount it to our fuselage. Here's an example on the 701 of that fairing, which we will install later when mounting to the fuselage. And the very top and tip of the rudder looks something like this. This is the part that we trimmed earlier. And there is our rudder completed. We will later mount the brackets for installation later when we mount it to the fuselage, so we don't have to worry about those details until we're ready to mount it to the fuselage. Good day. We are ready now to talk about the appropriate way to cut and shape our aluminum for the plane. First of all, let's talk about the aluminum product we're going to deal with. There's really two types of aluminum alloy that are commonly used in the construction of a light aircraft. One is called 6061 T6. That's the designation of the alloy. Another popular alloy is called 2024. You use the type of alloy the designer recommends. You don't make that choice yourself. So in this example, I have 6061 T6, and we will learn to cut this properly, and it doesn't matter what type of aluminum you're cutting. What's really going to make a difference is the thickness. Now, the designer will recommend the proper thickness based on the part you're about to make. What I have here are some examples of the various thicknesses. For example, what I'm holding here is called 16 thousandths. That's the thickness. That's quite thin. That's probably the thinnest you'll ever use in the construction of the aircraft. Here's the next standard thickness up. This is 20 thousandths, a little bit thicker. Here we have 25 thousandths. Now, if you're not sure of what the thickness of the metal you're working with, when you do purchase a large sheet, oftentimes the manufacturer will label the thickness on a protective film coating that's attached to the aluminum. You just peel that off when you're done working with it, but you notice this shows that this is 25 thousandths. That's the thickness. Going up in thickness, here's an example of 40 thousandths. That's a little bit thicker. Over here we have 63 thousandths. That's even getting more rigid, thicker. And here's an example of 90 thousandths. That's almost aluminum plate. Now, the reason I have all these samples out here is that we want to demonstrate how to cut them properly. And I'm going to start off with the thinnest of the material, the 16 thousandths. Now, when you're about to trim a piece of skin like this, you're first going to draw a line that's going to indicate where you're going to make the cut. And then the best tool for cutting this thin of aluminum is going to be these metal snips, or metal shears, if you will. They're really hand-operated snips. There are two types. There's a left-handed snip, or red in color, or a right-handed snip, or green in color. You might ask, well, which is the correct snip to make a cut like that? And it all depends on which side of your cut that you want to fold up. When you make the cut, this is going to curl or fold, and for the most part, you want the smaller piece to do the folding or curling. So in this example, the smaller piece is to my left. So I'm going to use what is called the red or the left-handed. It's not really left-handed, but it's the left snip. Now watch what happens. I'm going to hold the snip at a slight angle, makes it cut a little bit better, and I'm not going to take complete closing of the blade. I'm going to take small bites as I go. So notice I'm going to cut just outside the line, making small, careful cuts. I'm cutting outside of the line because that way I can go back and carefully trim and make a straighter line or use a file and clean up the edge. But notice how the left side of my cut is curling away from the larger side. That's why I'm using the left-handed snip. And I'm done. I can now either make a final cut to make that nice and straight, or I can use a file to clean that up. Let's do another example here. I'm going to make another line for my cut over here. I always use a ruler. I always measure off exactly where I want the line to be. I'm using my Sharpie permanent marker to make that line. Now in this example, if I turn this around, the piece that I want to cut off, or the smaller piece, is on the right side of me. So I'm going to use the green, or the right snip. Again, I'm holding it at a slight angle this way. It just makes cutting a little bit easier. And notice how this is curling up away. I'm cutting outside of the line so I can go back and trim it more carefully. Now, if I had chosen the red snip, then I would have been forcing the left side to curl up, and that would have been much harder to manage. The larger piece normally doesn't want to curl because it's much larger and more rigid. So the smaller piece is probably the side that you want to remove. And that cuts off. So, in summary, when faced with which choice of snips to use, it all depends on which is more convenient for you to make the cut. Do you want the left side or the right side to curl up because it's the smaller piece? You'll know it'll make much more sense when you pick these up and start cutting yourself. Now that worked just fine for the 16 thousandths. For the 20 thousandths, that's a little more thicker. The snips work just fine. For the 25 thousandths, the snips work just fine. It'll get a little bit harder to cut. Now for the 40 thousandths, that is going to get tough. The snips are going to be really hard to squeeze. You may want to cut this with the metal bandsaw. We'll look at that next. And certainly the 63 thousandths and the 90 thousandths, we're going to use our electric metal bandsaw to make those cuts. You want to make sure you always wear the proper eye protection. Sometimes when you cut small pieces, they will go flying. And the last thing you want to do is to go search for that piece that went flying and have to discover that you found it stuck in your retina. Not a good idea. So do wear eye equipment. Also, for the people around you, they would appreciate not having to run to the Band-Aid shop to take care of problems like that. In final, I want to make a comment in that you don't want to substitute thicker aluminum for thinner aluminum, thinking that maybe the part might be stronger by substituting a thicker metal. It's amazing how the excess of weight adds up. By the time you're done with your plane, you may find that the plane weighs 50 pounds or more than it should because you've been substituting thicker skins for the thinner. Use exactly whatever the designer asked for. There is no guesswork on your part. And that's the safe way to cut your aluminum skins. Now when it's time to cut aluminum thicker than, let's say, about 40 thousandths, 40 thousandths and thicker, your hand snips aren't going to do the trick. So you're going to need some sort of electric metal bandsaw. Now, it doesn't have to be a real heavy-duty one for steel, but the type of saws made for wood and non-ferrous metals actually do just fine. That's what I have here. This is a bandsaw, I have the proper blade for cutting aluminum, and typically you run these at a relatively slow speed. So I'm going to show an example of cutting 40 thousandths here. Basically, I've just made a line and I'm going to feed it through the blade. So a very handy machine to have for all of your thicker aluminum stock. Most important is eye protection, right? I'm going to make sure I have my safety glasses on, and that'll allow me to get up nice and close so I can keep a straight line yet preserve my bodily parts intact there. I'm going to go ahead and cut this guy. And that sure makes it easy. I'll clean up the edges with a belt sander or a hand file, and I'll be in good shape. One of the power tools you just can't live without around your shop is a power sander. I have a vertical belt sander here, but they come in all sizes, shapes, and forms. There are drum sanders, there's disc sanders, some sanders you put at the end of your power drill. But the point is, when working with aluminum, it's quite common to want to dress up the edges or round off corners, especially with your more thicker stock of aluminum. So I'm just going to clean up this piece that came off of the metal bandsaw and make it look nice very quickly. Got my safety glasses on. And there, in such little time, what I'm going to do is peel off the protective coating the manufacturer puts on. We've rounded off the corners and made the edges much more smoother, especially if this piece were going to be exposed on the aircraft. You want it to be a lot nicer. Now, we're going to go over to the table and show how we dress the edges of our thin aluminum skin using a hand file, because a power sander would be just a little too much for the very thin aluminum. It would probably catch the edge and make a real mess of that. In order to demonstrate proper drilling and riveting techniques, we're going to take this piece of 16 thousandths aluminum skin and attach it by way of drilling and riveting to this angle piece. And we want to attach it just like this. So let's demonstrate the steps necessary to do a proper drilling and riveting job on these two pieces of metal. Step number one, I'm just cut this from a larger sheet of aluminum, and I need to file the edge to make sure it's nice and smooth. Doesn't take long. By doing that, we have a smooth edge that will not cut the fingers. Doesn't have to be anything fancy, but certainly want to get the rough edges off. Now, I'm going to end up drilling a rivet line along this edge and into the lip of this angle piece. Something that's nice to be able to do is to use a wooden block to support my drilling effort. And then I'm going to set this up and create my rivet line along here and drill. Now I have a special tool for drilling that rivet line very accurately. I'm going to take a Sharpie marking pen, and in this plastic tool here, watch what happens. I'm going to insert this into the hole and tighten down this clamp. This is an edge marking tool. What it allows me to do is to create a line along the edge. And what's important here is that the designer of this aircraft wants a rivet line no closer than 10 millimeters to this edge. If rivets get too close to the edge, we're going to lose our strength. So I'm simply going to draw my 10 millimeter line just like that. So very quickly I have the ability to locate that line along the edge. Now the other thing I need to do is to locate the end rivets. Take this out here. And using my ruler, I'm going to locate 10 millimeters from the edge. And then 10 millimeters from the edge over here. Now, the designer wants the rivets to be spaced at 30 millimeter centers from this point to this point. Now, instead of trying to use a ruler and measure 30 millimeters across and try to get them centered perfectly between that, we have a very fancy tool here. This is a rivet spacing tool. It's fun to play with, but works like an accordion, but its real purpose is the following. Since I know that I need 30 millimeters between each hole, I can lay down a ruler and spread this so that I get it just exactly at 30 millimeters. There's 30, 60, 90, 120, etc. And that's what this tool is for, because now I can set this here, line this up, and notice it's easy to get the location of where I should drill the rivet holes. So with very short amount of time, that's where my hole locations are supposed to be. Now I'm going to go ahead and drill. I'm going to use a block to support my drilling. These are supposed to be 1/8-inch holes, or actually it's called a number 30 drill. I'm going to go ahead and drill these right where I marked them. I've drilled my holes. The next step is going to be to deburr the back of these holes. Now, if you were to look very closely at these holes, you would notice, and I'm not sure this is easy to see, that there are tiny little burrs or pieces of metal based on drilling through the sheet. You can almost see one right here. This needs to be cleaned off, because when this joins up against another piece, that metal chip could keep the two pieces from becoming very tightly connected to each other, because we want them to be nice and tight. So the easiest way to deburr this is I have a 1/2-inch metal drill covered with duct tape just to keep my hand from getting cut. And what I do is simply stick it into the hole and twist about a 1/2 turn, like that. Stick it in the hole and twist, 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 and twist. And I'm going to do that to the other side. Get all the holes there. And that deburrs. Another thing I can do is take a file and simply go across the surface, but that's just fine now. So that has removed the material on each side of the hole. Now remember, our goal was to attach this just like so. So I'm going to line this up along the edge, and I'm going to mark just one of the holes. Stick my pen in here and mark this hole right there. Now that's exactly where this needs to be drilled, so I'm going to go ahead and drill it. The same size drill bit, a number 30, which is approximately 1/8 inch. And then we're going to use a cleco to attach these two pieces together at that hole. And watch how that is done. Got the cleco. This is a copper colored cleco, and the cleco pliers. Stick that in there and I squeeze it. And the way this works is I go into the hole and into this hole right here, and that locks the two together. And by locking them together, I am allowed to then continue drilling the rest of the holes. And this, of course, is held extremely rigid and perfectly matched when I make the rest of the holes. Let's take a moment and stop and talk about these clecos, how they work and what they look like, because you'll be using a lot of these to hold your work together temporarily until you finish drilling and then later on riveting the pieces together. When it comes to clecos, there's basically three that we're going to use in our kit building. There's a black cleco, if you can see that, the body is colored black, and a copper colored cleco, get the copper color in there, and a silver cleco. These are color coded because if you notice, the black clecos hold a diameter hole of 5/32 or a drill size number 20. So these are essentially almost identical size holes. The copper colored cleco holds an 1/8 inch or a number 30 size hole, and the silver is for the smallest, a 3/32 or number 40 size hole. Now, when you drill a hole, the designer is going to specify what size hole you're going to use because that's going to affect what type of rivet can fit in the hole. So once you've decided which hole is necessary, then you can choose the cleco by color so that it will properly hold the holes that you have drilled. Again, clecos are used for temporarily holding two pieces of metal together based on the hole size. Now, there's basically two size rivets that are very popular in kit building, the A4 size and the A5 size. Their difference is obviously in the size of the hole that they take. Obviously, the designer will always specify what size rivet is needed for a particular part. Now, here's a close-up of a cleco. Very ingenious little device. It is spring-loaded. When we push this plunger in here, the end expands and contracts, because this is the end that will go into the holes that you're trying to put together. This is the cleco's pliers. It simply is a little squeezy job here, and it's made to attach to the cleco like this, and notice how I can just simply squeeze it. And as you squeeze it, if you can see the end expands and contracts so that as you place it inside of a hole, it will grab the two pieces together. So let's go ahead and see how we can use this cleco to hold our pieces together. So in our example here, I have my 1/8 inch hole, or number 30 drill bit made that hole. I'm going to use the copper cleco. I'm simply going to squeeze it, and that's going to allow it to fit into the hole and grab. Right now that cleco has grabbed. I can't pull it apart, but it becomes very valuable when I attach it now to the hole in the second part. So I'll take my cleco pliers, squeeze it, and then allow it to be inserted into both holes and release, and that holds the two together nice and firm. It's for a temporary holding together of the two pieces, and again, the purpose for doing that was so that I could drill the rest of my holes and have this hold it perfectly tight. So I'm going to go ahead now. I don't even need to mark the other holes, as I can simply drill right through the previously drilled holes. So I'm going to pick this one down here. I got my wood block underneath. Don't use your finger underneath there. And after drilling that, I can now take another cleco and put it inside of there. Now I have an absolutely firm connection between these two pieces. So I've clecoed these together. Again, this is just for temporarily holding these two pieces together. And there's the other side of the clecos there. So I'm going to go ahead and finish drilling the rest of the holes. They will be aligned absolutely precisely. And if I want, I could even add another cleco. But actually now, I have all of my holes drilled through both pieces of metal with the clecos holding these together. Now I'm going to take these apart and deburr the piece underneath. So I'm simply going to remove that. And I'm going to remove this one. And that will allow these pieces to come apart. And remember now, I need to deburr these holes. And once again, that's easy to do. I'm simply going to give a half a twist, give a half a twist. Doesn't take long, but very important because that burr in there will keep the two pieces from seating next to each other. And I'm going to flip it around and do the other side, because even if there's metal sticking up here, that will interfere with the rivet grip when we go to do our riveting, which is actually coming up next. Be our last step. Okay. I'll go ahead now and reconnect these with the clecos. I'll put one at this end, and I'll put one at the other end. And in fact, I'll put one right in the middle. Now, the reason I've done that is I can go ahead and do a rivet, and by holding the two pieces together very firmly with the clecos, it will allow me to perform my riveting. I get rid of the block of wood now. And we'll next now talk about the rivets necessary for joining these pieces together. All right, here's everything you need to know about pop riveting. Now, these are called pop rivets as kind of a generic term. We'll see that they're going to be installed with a pop rivet gun, but basically two of the more common rivet sizes are the A4 and the A5. Now, this designation comes from the fact that a size A5 rivet will fit a number 20 size hole made from a number 20 size drill bit, which is approximately 5/32 in diameter and uses the black cleco, as opposed to the A4, which is smaller in diameter, approximately a 1/8 inch hole, which is created with a number 30 drill bit and held together with a copper cleco. Both of these rivets are similar for the most part, except for their diameter. You can see that the A5 is much thicker in diameter. Now, the designer of the aircraft will always specify what size rivets are to be used for a particular application. Now, in the piece we're working with, we're going to use the A4 size. And if we take a slightly closer look at what this rivet looks like, it is made up of a stem, and we're going to insert the stem in the rivet gun. And in fact, let's take a look at the rivet gun and get a better idea of what that looks like. This is our rivet gun. It is obviously hand operated. There are pneumatic type rivet guns, but this is the one that's easy to use. Basically, you're going to squeeze, and the magic of the rivet gun is that when you squeeze, it's going to pull a plunger backwards. That plunger is going to grip the rivet stem and pull it in. In fact, let me load one of our rivets in here. So here's the rivet that we had before it gets away here. I'm simply going to insert the rivet into the rivet gun. Now, what happens is it automatically grabs the rivet. And if you watch what happens, now before I actually go ahead and squeeze this, I want to show you what's going to happen. The purpose of this is that we're going to take our metal piece, get that in the camera, and we're going to insert it into the hole. Okay, so that's what's going to end up happening. But before I put it in the hole, I want to show you what happens to the rivet when you start squeezing the handles. So I'm going to start squeezing. Let me give it another squeeze. You can see what happened. It's drawing the rivet stem up. Let me do that again now. It's getting shorter. And let me squeeze it one more time. And even shorter. Now what's actually happening here is that if you can picture your metal components that you're trying to tie together, this end is getting thicker and is going to hold the back end. And after you squeeze it a number of times, the stem will break off and will leave you with a fastener. And of course that just popped off. That pop is what a pop rivet is. If it doesn't pop, then I guess it wouldn't be a pop rivet. And notice now the stem will get ejected from the rivet. Now I just wasted a rivet doing that, but as a demonstration, I think that was well worth it. So let's go ahead and actually rivet our pieces together. So again, I'm going to take my rivet, insert it into the gun. I'm going to take the piece now. And remember, we have all these holes along the way. I'm just going to choose one of the holes. I'm going to insert it into the hole and start squeezing. And then we'll take a look at what actually happens. And at about, you heard the pop. Let's take a close look at what actually happened and what we were left with. On this side, we notice the domed head. If we compare that to the rivet, this is the way the rivet looked when we set it in there. So the stem broke off as we pulled the stem away, and on the other side, we're left with this little knob, and it's that knob, get that right in there, is what's holding the piece against the piece here. So we have a very secure, permanent connection on both sides. And obviously, this side is the finished side, where we got that nice domed head. We get a profile angle of that, nice and smooth with a domed head. And that's the principle behind the riveting. I'm simply going to go forth now and rivet the other hole. So I will load another rivet into the gun, insert it into the hole, start squeezing, snaps off. And now what I can do is remove the clecos. Don't need that one anymore, don't need that one anymore, and I don't need that one anymore. And all I have to do is fill up the other three holes. Again, loading the rivet inside. That breaks off. Eject the thing. That gets thrown away, that stem. Eject the stem. You get a whole bunch of those stems left over. Those are just going to go into the garbage. And the rivet is made out of aluminum also. The stem is actually steel. And we are done. We have just completed riveting these two pieces together, done a beautiful job. They are very secure, and we got the rivet head on the outside. This would be the finished side for the most part. It's much more pleasing to look at than the little knobs on the other side. But the good news is the two pieces are very well securely fastened together, will not come apart, and I can use some lacquer thinner on a rag to eliminate the line there, and you have your finished piece. And that's all there is to riveting successfully.